is 5 centimeters. And that is the only information I'm going to give you for this problem. So with that and that alone, we are going to find the area of this regular heptagon. I'm not going to give you the apothem. I mean, it's not like the last question, folks. Flip the sheet. Come on. Last question. I gave you the apothem, and I gave you the, well, practically I gave you the perimeter. If you have the apothem and the perimeter, you're done with the problem. You can find the area. This time, let's make it a little tricky. I'm only going to give you a side length, which you don't have the apothem. And, well, we kind of do have the perimeter, because if we take this and take that side length and multiply it by, how many sides does this have? 7. So 1, 2, 3, 4. I'm just marking this all out, folks. 5, 6, 7. This is going to be a perimeter of 5 times 7. What is that? 35? 7 sides. So that's going to be 35. So we can plug 35 in here. Area equals 1/2. Little a, I don't know. Perimeter is 35 centimeters. Got that. So ladies and gentlemen, to find the area of this regular heptagon, I've got my perimeter. I've got the equation all set up. The only thing I need is to find the apothem. The second I find the apothem, plug it in, type it into your nearest calculator, and you've got yourself an answer. So let's go ahead and find the apothem, shall we? Give yourself a center for the heptagon and give yourself a center for the circle. Now I'd like you to draw all the radii of this circle. So 1, 2. Notice how I'm not drawing the apothem yet. 3. We're drawing the radii. 4, 5, 6, and 7. There we go. Perfect. So there should be 7 radii. The apothem, oh, I love working with different colors. It's easier to see. The apothem, let's draw this right now. The apothem is right here. Let's call it little a. We need to find little a, folks. We have to find little a. Now this is the hard part of this lesson. So if you're starting to fall asleep, you're on your phone, you're playing an iPod game, I don't know. Put that stuff away and really pay attention to what I'm about to show you. I want you to start off by finding your central angle. Central angle. What's a central angle? That's a central angle. That's a central angle. You should have 7 equal central angles because it's a heptagon. If you do 360 degrees divided by 7 equal angles, it shouldn't come out nice and neat, everybody. It's going to be 51 point, I'm going to round it. Let's go 51.4 degrees. So every central angle is going to be 51.4 degrees. That's 51.4. This one over here is 51.4 degrees. And this angle is 51.4. They're all 51.4. If you take 51.4 and multiply by 7, you're going to get a full rotation 360. Now remember what the apothem does to your central angle. This red apothem cuts your central angle into 2 equal pieces. Now take that 51.4 and cut it in half, please. So let me punch this out. 51.4 central angle. Let's cut it in half. 25.7. We have this angle right here. 25.7 degrees. That is super hard. Can you see that? 25 point, that's blurry. And then this angle is also 25.7 degrees. Now I want you, because we're still trying to find the apothem. You know, we're working with central angles and 51.4, cut it in half. Yeah, okay, 25.7. What's the point, Mr. Kosal? I want you to focus on this one right triangle right there. And in fact, this is so important, I'd like you to pull this out of this entire figure. Pull this out of the heptagon, pull it out of the circle. I'd like you to redraw it, please. Here's your right triangle. I'll even make it the same color. Here's your blue right triangle. Couple things we know about this blue right triangle. I know that this angle right here is 25.7 degrees. I'm trying to find the apothem, and this opposite side is 2.5. This opposite side has to be 2.5 because think about this. If the total side length is 5, this is going to be half that side length, which is going to be 2.5. Can we find this side right here? Well, it's a right triangle. We know a lot about right triangles. We can use the Pythagorean theorem, which, you know, it's a great theorem. Unfortunately, it's not going to work for this problem. What will work for this problem is our good friend SOHCAHTOA. We need to use sine, cosine, or tangent in order to figure out this side right here. Now, if you forgot how to use SOHCAHTOA, just remember, this is your angle, this is your opposite side, this is your hypotenuse, it's across from your right angle. So we've got the opposite, we've got the hypotenuse, that means there's your adjacent. And I need to work with the opposite, and I got to work with the adjacent because I want to find this. I want to find the apothem, and I have the opposite side. I'm working with the opposite and the adjacent. Opposite and adjacent, folks. Let's do the tangent of 25.7 degrees equals, let's see, opposite, 2.5, all over the adjacent, which is little a. Let's solve, everybody. I'm going to multiply by a on both sides. A times the tangent of 25.7 degrees equals 2.5. And let's divide by the tangent, 25.7 degrees. So little a, your apothem, is going to be 2.5 divided by the tangent, 25.7 degrees. All right, punch that out. Let's figure out what our apothem is. Okay, this is going to be a little tricky. Here we go. Let's see if we can do this. Here we go. All right, get out of the light. The light is really bothering me, that reflection. Okay, let's go. 2.5 divided by tangent of 25.7 equals, I'm getting 5.19. I'm going to use 5.19. And get dot, 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 dot if you really want to be picky, because it goes on forever. So that is your apothem, everybody. This apothem right here, it's about 5.19 centimeters. Now remember what we're trying to do. We are trying to find the area of this regular heptagon. So we're using 1/2 little a big P. I got the big P. I got the perimeter. Now we just need the apothem. So take this apothem, 5.19. In fact, I'm not only going to plug it in there, I'm going to keep it in my calculator. Because if this is the apothem, all I need to do is multiply it by the 35, which I'm going to do right now, perimeter. So that takes care of these two. And now I need to multiply it by 1/2. And folks, we're done. So divide by 2. Here's your answer. Your area of the heptagon is 90.9. Let's go. Yeah, let's round to the nearest tenth. 90.9. And what are my units? Centimeters squared. That's it, folks. 1/2 little a big P. Use the equation. Use SOHCAHTOA when you need to, and I'll get you the answer every single time. All right, here is your homework. Remember, it's your review guide. And this is going to be due on Monday. Don't turn this into me. If you want to turn it into me today or even over the weekend, that's fine. But this is absolutely due on Monday with your binder. AKA, I need 11.1 through 11.4. I need these notes. Shoot them over to my email. I'll get you the grade. I'll reply. I'll let you know exactly what you got. But here's your homework. Here's your review. It's page 826. It's 11 to 24, and then 25 to 29. Now, it seems kind of ridiculous. Why didn't you just write 11 to 29? Because 25 to 29, this is 11.4. And this is the most important part of this review guide. You really need to make sure that you are doing these problems right. If you need to check answers, feel free to check answers. I don't have the answers for the review guide. If you want to ask me what answers are, feel free to shoot me an email, and I'll get back to you. But be ready for this quiz. Be ready for this quiz on Monday. Once again, review guides, binders, they're due. If you have questions, don't hesitate to contact me. Shoot me an email, and I'll definitely get back to you. Have a great weekend, folks. We'll see you for the quiz on Monday. Take care.